So now we'll move into a more advanced feature, which is the periodic advertising with response, which is coming from Bluetooth Low Energy 5.4 specification, and which for sure is supported over the STM32WB0 family. So the idea here, on top of emphasis that yes, STM32WB0 is targeting low-end, low-power application, but let's say in terms of BLE is targeting high-end, I would say state-of-the-art specification with the support of the 5.4 and this periodic advertising with response. So in this section, first of all, we would like to go into some concept. What is the periodic advertising with response, okay? And what are the applications targeted behind? And then for sure, we will demonstrate, I will demonstrate periodic advertising with response using STM32WB0 code example, okay? I will use already pre-flashed binaries, but which are part of the code example, part of the STM32WB0 package. What you will need in order to replicate this demo at home, okay? First of all, as you can see, if we are dealing with periodic advertising with response, okay, as you can see on my desk here, there are two entities, okay, one observer and one broadcaster, okay. So that's why you will need two boards, okay, one acting as an observer and the other one as a broadcaster. So you will need two Nucleo WB09. Here we use Nucleo WB09, but the feature is supported across the full family. And the Nucleo will be connected to your laptop through USB cable in order to get TeraTerm, Docklight, what you want, Hyper Terminal in order to get some logs and in order to demonstrate the communication between the two entities. Okay. Now, before moving to the demo itself, what is periodic advertising with response? So this is a connectionless technology. But let's try to understand first the bit background behind. You are familiar now with Bluetooth Low Energy, and you understand that, okay, a long time ago with the release 4.0, so the first release of Bluetooth Low Energy, the advertising mode has been introduced. Okay, this is typical from the Bluetooth Low Energy, so first release, where you do have the capability for peripheral to broadcast. And this is what we have done either in the beacon and in the P2P server to broadcast some data over the air to allow a central device to be able to read your data, okay, to say that, okay, you are here, and later on I will be able to connect. So there is a peripheral that allows to broadcast some data. This is really efficient, simple to put in place, but unidirectional, okay? Here you can only push data from the peripheral to the central, okay? The only way to move to a bidirectional communication is really to enter into connected mode, which is the other, let's say, mode of the Bluetooth Low Energy. Either you are advertising, connected. Okay, in connected mode, right, you can enable and do a bidirectional communication from central to peripheral, peripheral to central. But let's say you are entering here in a more, let's say, complex system where you do need to enable connection procedure, pairing, and so on, and which is not so scalable, because if you need to add a new peripheral, okay, you have to create for a new connection, okay, that will give less room for the first connection and so on and so on. So you will have to play with the connection interval and so on. But this was the only way to move to a bidirectional communication between two entities in BLE. Now, thanks to BLE 5.4 introduction, periodic advertising with response feature has been introduced, okay? And this periodic advertising with response feature is a way to establish a communication between two entities, and here we'll name it the broadcaster and the observer, in a connectionless mode. That means we are really using here the advertising extension concept and associated format channel in order to be able to establish a bidirectional communication between the two entities. So this is, of course, a new way that should bring new applications. Moving forward, okay, that's clear. What is the concept of periodic advertising with response? Clearly, this feature is really sensitive and suited for, let's say, low power application that need to send and receive message between a central that we'll name a broadcaster, which is the hub, by the way, and a large number of devices in the network that are called observer. And what is the concept? The broadcaster, using advertising extension, let's say concept, will push for some data at some specific period, okay? The observer, in the opposite, will wake up at those specific interval, okay, that are named the periodic advertising frame. So the observer will be able to wake up, okay, to read at the data coming from the broadcaster and to reply to the broadcaster, okay? Of course, prior to this bidirectional communication, there is a need for the two entities to be really connected in the sense of Bluetooth Low Energy to exchange this famous periodic advertising frame, which is the trigger for the observer to know, okay, I need to wake up at this specific interval because this is where the broadcaster will push data. So I will be able to collect and to respond. So this concept is based on advertising extensions, okay. It has been introduced with the BLE 5.4, supported over WB0. It allows to enable bidirectional communication in, let's say, connectionless mode, okay. And as you can understand, one of the first strong interest is the energy efficiency of the observer, that only to wake up at some specific interval and to sleep again, okay. Again, this is something scalable because you can add a new device in your periodic advertising network easily. You just need to inform the observer about what is a periodic advertising train, and then, okay, he's part of the network, okay. What are the applications behind? The first one is the one that you might heard a lot already, which is the electronic shelves label, okay, those small, tiny devices that you will find in all supermarkets in the world, which are today, by the way, wireless, based on time to time sub-gigahertz, 2.4 gigahertz, and now becoming more and more based on periodic advertising with response, okay. You've got the hub in the supermarket capable to update any tag or to receive any data from the tag. So this is very efficient in terms of energy. And that's true. The electronic shelves label is even a profile now of the Bluetooth Low Energy specification. An electronic shelves label application has been the one that has been used to push for this periodic advertising with response. So the first application, and which is now a profile, is the electronic shelves label. But now there is not only this application, it can open to a lot of applications, especially when we are dealing with monitoring, okay? Let's take hospital, healthcare, or industrial application. You just need to monitor. There is a hub that just need to monitor something in the system. So there is a basic tag, okay, either in a clinic room, okay, or on a tool in industrial that will wake up at specific event and will, okay, reply to some request from the broadcaster, okay. So really, this is really efficient, and this should open to a lot of new application behind, okay. And this will be your job, by the way, to potentially have some new concept, new idea, and to create such kind of application. So moving a bit more dive inside periodic advertising with response, but I will not spend too much time here. I really encourage you, if you want to get more input, to go to the SIG Web Alliance, or the Bluetooth Web Alliance, where you will find a lot of literature, those charts, by the way, to explain the concept. But what is the concept behind? Again, we do have two entities, broadcaster, observer. Broadcaster is the one pushing for some data, okay? The observer is the one collecting the data, but capable to reply. So what will happen? First of all, the technology is a bit like the TDMA technology, so we are splitting the time, okay? And the broadcaster is pushing some data over the air on some sub-event. Okay, sub-event is more or less the way to do some group. Okay, so let's say a sub-event is a group. So the broadcaster will push for some data for group 0, sub-event 0. Okay, so the data will be pushed over the air. Okay, over advertising extension, and those data will be pushed on a specific slot. Okay, T0 slot here. Okay, and those data will be pushed at each periodic advertising interval. Okay? So broadcaster is pushing data at T0 for group 0, okay? Every periodic advertising interval. That could be 30 milliseconds, 10 seconds, okay? At the end, it's a matter of compromise between latency and power efficiency. In the opposite, the observer, okay, which is aware of the periodic advertising interval, so what we call the periodic advertising train, will wake up, okay? All the tag part of the group 0, sub-event 0, will be able to collect the data on the slot T0. And this is the magic behind, from specification point of view, each tag, each device will know that, okay, I'm part of group 0. I know that I have to reply on this specific slot, which is the periodic advertising response slot. And at the end, you've got the periodic advertising with response with, again, the two entities here. Okay, now in order to play with, what is ST offering? The STM32WB0 family supports first the periodic advertising response. And inside the package, inside the STM32WB0 package, and let me open here. So if you install STM32 Cube package that is available on st.com, then you will find project, application, okay? And part of application, you will find some BLE application code. And this is where you will find beacon, P2P server, earth rate, and you will find as well periodic advertising, okay, broadcaster and observer. So yes, there is two sample code, one for the broadcaster, one for the observer. And the way our code has been generated is that our code example, which are based on periodic advertising with response, enable more or less an electronic shapes label use case. So the broadcaster will be seen as the access point, the hub in the supermarket that will push for some data to the tag. And so the observer are using the tag role, okay? So at the end, what do you need? 2 Nucleo boards, that's clear, okay? The observer, here on my desk, and the broadcaster, okay? And both, okay, broadcaster is, let's say, the access point, okay? And the observer is the tag. And we need 2 dog lights, okay? So let's start to play with. Sorry. So first of all, I will connect the broadcaster. So let me connect the broadcaster. Okay. I connect the broadcaster. Okay. And let's open the associated dog light. Let's clean the window. Okay. So I just open. So here I've got the broadcaster, the associated hyperterminal. Okay. Again, the broadcaster is the access point. Okay. The hub in the supermarket asking to update the tag. So if I press reset on the board, okay, what I can see, I have some logs here. Okay, again, I've got the stack initialization, what is the output power I want to use, okay. And at the end, okay, there is a configuration, if you can see here, where we are specifying to the stack, okay, I am the broadcaster and I will broadcast data every 300 milliseconds, every 1 second, and so on. So this is what we call the periodic advertising train, the way that you will wake up to push data over the air. And those data, this periodic advertising train, we have to inform the tag about it, okay? And the only way to inform at the first step is to enter into communication. So that's why first the access point, the hub in the supermarket, will start a connection procedure to the observer. Okay, it will try to connect to the observer to inform him about, okay, you will have to wake up at this specific periodic advertising train, and then we'll be able to enable a bidirectional communication without the BLE connection procedure. Okay. Fine. So now let me do the opposite and plug the observer. I plug the observer. I open the associated dog light. Okay. And if I press reset here, let's have a look about the logs. Okay, what we can see. Again, we do have here as well stack initialization, takes power level, stack initialization, okay? And then the tag is moving first into the advertising state, saying, hello, I am here. Okay, I'm ready to enter into your periodic advertising train network. So what will happen? So the tag is advertising. The observer is advertising, saying, hello, I am here. And in the meantime, you remember the broadcaster was trying to enable a connection. And if we have a look now to the logs, the broadcaster, the supermarket access point, is trying to enable a connection. And indeed, the tag, which was advertising, saying, hello, I am here, we succeed to connect to the tag. Here we are. So the tag is connected. We do have a connection complete event. So we are connected each other physically in sense of Bluetooth Low Energy. We are connected. And what are we doing? We are connected. So now we are just informing the tag, okay, I am the broadcaster. I will push some data every 300 milliseconds typically. So I will inform you about what we call the advertising train. And we do this through a procedure which is named PAST. Okay, this is BLE stuff. So we are pushing the data to the tag to let him know, okay, you will have to wake up at some specific timing. And this is what we can observe here. We do receive the advertising data, the periodic advertising train data. And then we move to disconnected. Okay, on both sides. Okay. So now, if I clear the both, what is ongoing here? The broadcaster is pushing for some data every 300 milliseconds, okay? Even some control byte just to maintain the link, to know if the tag is still there, okay? And the tag just wake up at those 300 milliseconds. It could be more, of course, just taking an example here. And in short, we are able to exchange such data with this periodic advertising train. So now what I want to do, I want that my access point in the supermarket will trigger a light here on the tag just to make the tag appealing, okay, flashing to let the people know that, okay, there are some promotion here, okay. So what I will do, from the broadcaster, I will send some data, okay. And as we are based on electronic shapes label, we are using AT command. So what I will do, okay, I will just basically trigger a LED on, okay. And indeed, the LED is on here, on the bottom here. You should see that the LED is on. If I do LED off, now the LED is off, okay? So for sure, if the periodic advertising train is 10 seconds, you will get a long latency, but in supermarket, it's acceptable, okay? So LED on, LED off. So here, basically, we are just making a light LED on off, but we are doing it not in connected mode. Really, we are not connected. We are using advertising extension concept. And indeed, what we can see, when I was willing to switch on the light, the broadcaster is sending some advertising data to the tag. Okay, the tag receives the data, okay, through advertising channel, and the tag has been able to reply over the advertising frame, okay, and we see that the LED is on, okay. So again, we are just toggling a LED, but again, we are toggling a LED no more in connected mode, but really using the concept of periodic advertising response. And if we have a quick look, I will not plug, but you have seen that here on my desk, I have this nice ST-Link V3 power tool, okay, that I have used to monitor the power consumption on the observer. And if I look at such logs on the observer, okay, what we can see here. Basically, here we can see again we are on the observer side. I'm monitoring the observer. What we can see that the observer wake up indeed at some specific interval. It just wake up, okay? To listen if there are some data from the broadcaster. So it will wake up, and typically if we zoom a bit, okay, I will wake up and I have this, I would say, Eric's window where I will just listen to some data, okay? And now, if there is really some data over the air, on top of having just a basic Eric's, and here we are, I've got my Eric's here, and on top I'm able to reply, okay? But all this bidirectional communication Eric's takes is not done in connected mode, but again, based on the advertising extension concept with the periodic advertising with response, okay? Which allow really to enable some nice new application. So what to take from this demo? So first of all, you will be able to replicate, okay? And then, yes, WB0 is really state-of-the-art in terms of BLE and supporting the periodic advertising with response feature. And behind this, of course, our code example is based on electronic shapes label, but you do understand that this allows to enable some new, let's say, scalable network application where they are really triggered by the power efficiency. So it should trigger really some new application, new concept for the BLE market.